So in this video, we'll solve question number 2 of ISC Computer Practical 2005, which was on Wondrous Square. So let's begin. A Wondrous Square is a n by n grid which fulfills the following conditions. So it is an n by n grid, means a two-dimensional array of size n by n. It contains integers from 1 to n square where each integer appears only once, which means that if the size of the square is 4, we'll be filling that with numbers from 1 to 16 such that each number occurs only once. And they are saying that the sum of integer in any row or column must add up to, and they have given a formula for that. So there are two things: each number should occur only once. There is a range of numbers from 1 to the n square, plus the sum of all the individual rows and columns should meet this criteria. Okay, and then they have given a certain test cases, like for n is equal to 5, this is a Wondrous Square. And other than testing for whether or not an array is Wondrous Square, we are doing one more thing, and that is we have to display the prime numbers along with their row and column index. Like in this case, they are saying that 2 is a prime number at column 0, row 3. So it's a 0 based indexing, and we have to display all the prime numbers in the square along with their position. And there is one error in the question where they are saying that 15 is a prime number. So obviously this is an error and we won't be doing it. So 15 is not a prime number. So let's begin with the thing. So the first thing which we have to do is we have to take the input, that is n is equal to followed by the array itself. So we go over here. I already have a template ready. So what we'll do is we'll first enter the number. We'll say that okay, int n is equal to in dot next int, and obviously we have to display the message also. So here I'll say that n equal to whatever the value of n is. Once this is done, we have to enter the value. So I'll take two nested loops, one for row and one for column. So int row is equal to 0, row is less than n, and then row plus plus. This will be followed by the loop for the column. So int col is equal to 0, col is less than n, and then we'll say col plus plus. So there are two loops for rows and columns. Once this is done, we have to enter the values, and before that we have to create an array. So I'll say that okay, int a, two box bracket for one for row and one for column, is equal to new int, and then I'll say n. So this creates the array. And now we have to enter values in this array. So I'll say row col is equal to in dot next int. So once this is done, our array is populated. After populating the array, now we normally write a full-fledged object-oriented program. So we'll create a class. We'll call our class as a square, and then I'll say that okay, square sq is equal to new square, and then we'll pass the array, that is a. Once this is done, computer will look for the class, and then it will search for the constructor, and the value, or rather the array a, will be passed. Once that is done, we'll have our function which we'll be calling is Wondrous Square to check whether the square is a Wondrous Square or not. So we'll check if sq, hold on, not over here, after the output will display. So we'll say if sq dot is Wondrous Square. If it is, then we'll display one message. If it is not, then we'll display another message. To display the message, I'll quickly copy paste the system.out.println line, and then I'll copy paste the message also. So if it is a Wondrous Square, we have to say yes, it represents a Wondrous Square. So I'll copy it and I'll paste it in the if block. And if the computer goes into the else block, we'll copy the message, not a Wondrous Square. So this will take care of the messages, Wondrous Square and not a Wondrous Square. Once this is done, we have to print the prime numbers along with their location. And what we'll do is we'll say system.out.println, and then we'll say the name of the object. So basically what we are doing over here is we are directly trying to print the object. So computer will try to convert this into a string, and if there is a function by the name of toString, it will call that function. So what we'll do, the logic of printing the three columns, that is the prime number, the row index, and the column index, will go inside the function toString. So let's begin with our class definition. We'll go at the top and we'll say class square. Within the class square, we are supposed to have our data members. So the data members are, we'll have our array. So private int a. So first thing is we'll have our array. Then we'll have the length n. We can manage it without the length also. We can always say a.length, but that is too much of typing. So I'll prefer taking a variable n. And then we'll have one variable for storing this, the expected sum, the one which we'll get by the formula which they have given. After that, we'll have our constructor. We'll say public square. We'll accept the array a, and then we'll store it. We'll say this dot a is equal to a, and then we'll also say that this dot n is equal to the length of the array, a dot length. Now, once this is done, what we need to do is we have to have this function, or rather the formula. So this is the formula which we have to take, 0.5 into n squared plus 1, and this will give us the sum. So we'll say that sum is equal to, we'll have to typecast everything into an integer, and the formula was 0.5 into n square, into n square plus 1. So this will give us the expected sum, which we'll compare when we reach the other. There's one bracket missing. So we have got all our brackets. So this is done. So initialization is done. Then we have to have a function for checking. So we'll say public boolean, because we are supposed to return a true or a false answer, whether or not it is Wondrous Square. So if is Wondrous Square, so that's our function. And now we have to check whether or not it's a Wondrous Square. So we have to do two things, or rather three things: sum of rows, sum of columns, plus whether or not each number is occurring only once. Now, in order to test whether or not each number is occurring only once, what we'll do is we'll take a Boolean array which will act as a flag. So I'll call it flag. And this is for each of the digits which can come, whether or not they have occurred earlier. So this will store true and false. So we'll create an array of size n square. So I'll say is equal to new Boolean, and the size will be n into n. So the 0th location will store whether or not 1 has occurred. The first location of this array will store whether or not 2 has occurred, and so on. And then we'll have variables for holding the rows, rather the sum of rows. Then we'll have variable for holding the sum of columns. And I think that's all for now. Now again, we need two loops, one for the rows and one for the columns. And in order to save some time, I'll just copy it from the input portion. So there we are. This is our loop. Obviously, we don't require to enter it. So I'll remove this line from here. So now outer loop is for rows, inner loop is for column. And before the inner loops begin, we'll initialize these variables to 0. That is, sum of rows will be equal to 0 and sum of columns will be equal to 0. And then we'll find the sum of rows and columns inside the loop. That is, inside the loop, we'll say that, okay, sum of rows plus is equal to a of row column. And then we'll say that sum of cols is equal to, and this will be the reverse. That is, instead of row column, we'll say col and row. So this will find the sum of row and sum of columns. And then we have to check for the repetition. So we'll first check that if flag of Flag of what? Flag of A of row column. If this number, and we have to do -1 because the array indexing is starting from 0. So if this -1 is equal to true, that means if it is true, that means that the number has already occurred, and in that case we'll just say return false. And if it is not true, then we'll go to the line following it and we will make it true because that number has been found. So we'll go over here, I copy this, and here I say this is equal to true. So this is how the flag system will work. Now, once we are outside the inner loop, we'll check whether or not our rows and columns are okay. That means whether the sum of rows and sum of column variables are storing their expected values. So I'll say if sum of rows is not equal to the expected sum, or the sum of cols is not equal to the expected sum, we'll say return false. If we reach the end of the function, it means that the square is a wondrous square, so we'll say return true. So this takes care of the is wondrous square logic. Next thing is we have to display whether or not we have to display the list of prime numbers along with their rows and columns, and for that we'll use the toString method. Now please note, toString method is automatically called whenever you try to convert an object into a string. Like if you normally try to print it, computer will try to convert it into. Note that over here square is actually a reference variable or an object. We are trying to print it, computer will search for this function, and if this function exists it will be called. So here we'll form our output and then we'll return our output. So we'll say that output is equal to, and the output consists of 3 columns. Those 3 columns are prime, row index and column index, and in order to save some time I'll copy it and I'll paste it. So this is how it goes, but I don't want to give spaces, I'll give /t in between so that the column changes looks nice. /t, and then there should be a /n at the end. So this is the initial value. Now again we have to traverse the entire loop. So in order to traverse the loop we'll require 2 nested loops. So I'll copy paste this over here, and here we'll do the forming of the output, which is actually quite simple in our case. Now before we can proceed, we have to check whether or not if it is prime. So I'll make a function for that also. So let me first call this and then we'll declare the function. So if row call, if it is prime, then we want to form the output, and the output will be output plus is equal to, we'll have to first display the number, that will be followed by /t, that will be followed by the row, that will again be followed by a /t. In fact 2 /t's because the messages are long, so /t, and then we'll add the column, and finally at the end we have a new line. So once this whole output is formed, this is row not rol, we'll return this output. Now there is only one thing which is left, and that is the is prime function. So what we'll do, we'll come over here, we'll say private static boolean is prime, and we'll check whether the number passed or the argument n is a prime or not. Now sometimes students, what they do is they first count the number of primes and then they check it against 2. Now that is a very bad way of doing things, so we'll have a slightly better version of is prime, and in that what we'll do is we'll check for the exception cases before. So if n is less than 2, it cannot be prime, so we'll straight away say return false. If n is equal to 2, please note that 2 is the only even prime number, so we are checking it separately. So if n is equal to 2, we'll say return true. Otherwise, when you reach over here, it means that n is more than 2, but it may be even, it may be odd, and even numbers other than 2 are not prime. So we'll say n modulus 2 equal to 0. If it is even and it is not 2, we'll say return false. So this becomes the prime number thing, and then If you are reaching this last else block, it means that the number is odd. Now, in order to avoid repeated division, we'll not take the loop till the end. We'll have our limit, and that limit will be actually math.sqrt. So we'll say math.sqrtn. We will not go beyond the square root. So for example, if the number is 100, it cannot be 100, will be 101. So let's say if the number is 101, the square root is 10 point something. So we will not go beyond 10, and we'll have one more optimization, and that optimization is that our loop will start from 3. Please note, we have already checked till 2. So our loop will start from 3. We'll go till it is less than or equal to limit, and then we'll add it by 2. We will not make 3 into 4 because the number is odd. So I plus is equal to 2. So if the number is 101, our loop will run from 3, then 5, then 7, then 9. So once this is done, now please note, we are not starting from 1, we are not going till the number. So if we find a divisor, that divisor has to be something other than 1 or the number itself, which means that the number is not prime. So if n modulus I equals 0, we'll say return false. And if we reach till the end, we'll say return true. So I think this takes care of everything. Seems so. Let us run the program and see what happens. So the first test case is over here. N is equal to 5, and this is the test case. So I'll just copy paste it again to save some time. We go over here, and then I run the program. I say n is equal to 5. I press enter. I enter the numbers, and then there we are. Yes, it represents a Wondrous Square, and then we are getting all the prime numbers 17, 23, 5, 7, 13, 2. Right. This is working. Let's check the other cases as well. The other case means n is equal to 4 followed by this. So we come over here. I again run the program. So n is equal to 4 followed by this. So yes, it represents a Wondrous Square. Again, we are getting all the prime numbers. So this also is working. And then there is one more case. And obviously we are not getting this 15 because 15 is not a prime number. That was a mistake. And then n is equal to 3 followed by this array. Again copy, we again go here and we again run it. So n is equal to 3, Control Shift V, and there we are, not a Wondrous Square, and we are getting our list of prime numbers. And finally the last case, n is equal to 2, and then the array consists of just these 4 elements. So I come over here, I again run the program, n is equal to 2, and there we are. So our program is working for all the test cases. So if you have any issues with the question, you want any clarification, you have any doubt, please feel free to use the comment box below. Thank you.